Let us take one more problem on dipole. 2-point charges Q1 and Q2 of magnitude 10 raised to minus 8 coulomb and 10 raised to minus 8 coulomb. That is the point now for dipole. The Q1 and Q2 should be of same magnitude but opposite polarity. Okay, one is plus, one is minus. Magnitude is same, 10 raised to minus 8, 10 raised to minus 8. Coulombs respectively are placed in 0. Here is Q1, here is Q2, placed at 0.1 meter apart. Okay, calculate the electric field at the points A, B, C. One point A is the midpoint actually. A is the midpoint and B is midpoint on the axis and B is why it midpoint. Look here, total distance is 0.1. This distance is 0.05 given. Therefore 0.05 plus 0.05, that's equal to 0.01. Okay, 0.01 by 2 is 0.05. Therefore A is the midpoint. B is on the axial line. So another point C is on the equatorial line because it is the perpendicular one and passing through midpoint. Therefore it is equatorial line or equatorial plane. First of all, let us work out. One point is to be remembered. We have derived the electric field at a point on the axial line and the other equatorial plane. Okay, at a point on the axial line or equatorial plane. But the point should be not within on the axial line. Even though it is on the axial line, so it should not be within Q1, Q2. Within the point should not be taken. The derivation is not applicable for the points on the axial line which are within Q1, Q2. Within these, what it is, this internal point, I can call it an internal point, and the axial line is not possible. That formula is not applicable, not possible, not like that. So on the internal point of Q1, Q2, that formula of field at a point on the axial line is not applicable. Only on the external point means the axis Q1, the line of Q1, Q2 is extended on either side. Then on that point, extended portion of the axial line, that formula is applicable. The electric field at a point on the axis at a point on the axial line, that point should be not internal one, not within Q1, Q2, but it should be on the extended portion of Q1, Q2. Okay, I understood that one important point. Okay, for B, we can apply the dipole technique. For C on the equatorial point, a point on the equatorial plane, the dipole formula is applicable, but not for the point A, because point A is within the axis. Within the axis, formula is not applicable. Okay, for the point A, let us work out the field E1 by the charge Q1 is radially outwards. Why? Charge is positive, therefore field at the point A is radially outwards. Okay, for the point Q2, for the charge Q2 negative, the field is also towards the charge. Okay, E2 bar. The charge is negative, therefore its field Q2 at the point A is radially outwards. Sorry, towards the charge. I'm sorry. For the point, for the charge plus Q1, the Q1 is positive, then the field at the point is radially outwards. If the charge is positive, field is radially outwards. If the charge is negative, field is radially inwards. Therefore, Q2 is negative, field is towards the charge. And Q1 is positive, therefore field at the point is radially outwards. Means both E1 and E2 are in the same direction. Therefore, EA bar is what? In the same direction. EA bar is the resultant of what? E1 and E2. That should be in the same direction as that of E1 and E2 because two vectors are acting in the same direction. Resultant is also in the same direction. This is EA bar. Okay. But I can't apply the dipole formula to put the field at the point A because dipole formula for the field at a point on the axial line where the point should be external point, not on the axial line, not on the internal points. So how to work out the field at the point A? So work out the field due to the charge Q1, work out the field due to the charge Q2 at the point A. They are E1 and E2 respectively and both are acting in the same direction. Therefore, EA magnitude EA is equals to E1 plus E2. Two vectors are acting in the same direction. Then the resultant is R is equals to P plus Q. Acting in the opposite direction, then R is equals to P minus magnitude. We are talking about the magnitude. So actually, This is 0.05, this is also 0.05. Therefore, the distances are same, charges are magnitudes are same. Therefore, E1 is equals to E2, magnitude E1 is equals to E2. R is the now, what is the R here? R is the distance between the, for a single charge, R is the what? Distance between the point and the charge. Therefore, first one, A is the midpoint. A is the midpoint of DC, where DG, I have taken this point as G, this point as D. Okay, DG. Therefore, E1 is equals to E2 is equals to 1 upon 4 pi epsilon naught into Q divided by R square. R is equals to what? Distance between the single point charge. R is the distance between the point and the charge. Point is at what point you would like to calculate the field, that point and the charge. R is equals to what it is? It is D. What it is? DA, or it is equals to AG. Okay, G. Both are 0.05. Both are equals to 0.05 meter. Given it is. Okay. That's equals to 9 into 10 to the power of 9. Q is what it is? Q is 10 to the power of minus 8. Magnitude of Q is to be taken. Modulus of Q, when you are calculating what it is, magnitude of the field here. Modulus of charge should be taken. R square. R is 0.05 the whole square. Okay, that's equals to 10 to the power of 9 into 10 to the power of minus 8 is 9 minus 8 plus 1. 9 into 0.1 upon 0.05 the whole square is 0.025. I'm sorry, 0.0025. That's equals to 9 upon 0.0025. Just 10 to the power of 1 now. That's equals to 90 upon 0.0025, 10 to the power of 9 into 10 to the power of minus 80, 9 plus of minus 8, 9 minus 8 plus 1, 90 upon 0.0025, 0.5 the whole square, 0.05 the whole square, that's equals to somewhat 36,000. Sorry, that's one bit. 90 upon 0.0025 equals to 36,000. Yes, it is. 36,000 means 3.6 into 10 to the power of 4. 4y. 1, 2, 3, 4. Left side it is shifted. Therefore, into 10 to the power of 3.6 into 10 to the power of 4. 4 point is shifted. 4 point left. Then 10 to the power of 4 should be taken. So now, what is the resultant field? EA bar, EA, magnitude of the resultant field, EA is equals to E1 plus E2. Field at the point A, EA is equals to, then the question, what is the field at the point? Field at the point, A is equals to EA bar. Okay. Let us write EA bar is the field at the point A. Let us write it, please. That EA bar is the resultant field. Resultant field at the point A. Okay. EA is equals to E1 plus E2. Why E1 plus E2? Both are acting in the same direction. Magnitude of the resultant. EA means only magnitude. EA is equals to E1 plus E2. That's equals to 3.6 into 10 to the power of 4 plus 3.6 into 10 to the power of 4. Therefore, A plus A, 2A, 2 into 3.6 into 10 to the power of 4. It is not A plus A, it is 2A, same quantity is added 2 times. EA is equals to E1 is equals to E2. Because why E1 is equals to E2, magnitude of the charges are same, distance R is same. This is not the dipole concept. It is a field due to a single point charge. 1 upon 4 pi epsilon charge upon square of the distance between the point and the charge. That concept is applied. So E1 and E2 are the field due to the charges Q1 and Q2. So since both magnitude are same, distances are same, therefore the magnitude of field due to the individual charges Q1 and Q2, yeah, E1 and E2 are same. E1 plus E2. Why E1 plus E2? Both are acting in the same direction. The resultant R is equals to P plus Q. Magnitude of the resultant R is equals to P plus Q. That's equals to 7.2 into 10 to the power of 4 newtons per coulomb. Let's write the direction of finally E a bar. It means a vector quantity. You have to give the direction also, otherwise we are losing 1 mark. E a bar is equals to 7.2 into 10 to the power of 4 newtons per coulomb along E a bar is also in the direction of E1 and E2. E1 and E2 is along AG. A to G, no? Okay. A to G. When two vectors are acting in the same direction, resultant is also in the same direction along AG. Okay. Second one is field on the axial line. Okay. Where the point that point is not mentioned in the textbook also. That even though it is dipole, so the derivation is field on the axial line. Two derivations are there: field on the axial line and equatorial line. So field at a point on the axial line and equatorial line. The field on the axial line, that formula is applicable only for the external points, not for the internal points. See, even though the point A is on the axial line, but it is an internal point, therefore that dipole concept should not be applied. So here it is. Individual fields are to be calculated at the point A and both are to be added. Okay, but at point B, it is an external point. It is not Q1 and Q2 is here. This is an outside point on the axial line. For that one, dipole concept can be applied. Okay, so point B is an axial line. Field at the point B. Okay, field at the point B. At the point B. Okay, on axial line. On axial line, external point. Okay, external point. Therefore, dipole concept can be used. On field on the axial line, the point should be field on the at a point on the axial line, the point should be external point. Then only dipole concept can be taken. Now, is it a short dipole or a long dipole? Look at now. Here comes R. The R is nothing but, for a dipole concept, R is nothing but distance between the point and the midpoint of the dipole. Okay. What is the R here? R is equals to dB plus it is AB. AB is equals to, I will to work out the field at the point B. A is the midpoint. Actually, for dipole theory, no, field on the axial point and field on the equatorial point, R is what? Distance between the midpoint and the point. Therefore, AB is the R. AB is equals to, it is dA plus dB, both are equal to 0.5, 0.5, 0.01, sorry, 1 meter. And what is the A? Here, distance between 2A is equals to 1 meter, Q1 to Q2 is the axis of the dipole, that's equals to 2A, 2A is 0.1 meter, A is equals to 0.1 upon 2, that's equals to 0.05, 0.05 means 5 centimeter, R is 0.1 meter, 10 centimeter, 5 centimeter is not smaller as compared to 5 centimeter not smaller as compared to 10 centimeter. Therefore, short dipole concept should not be used here. For short dipole concept, A should be very very small as compared to A is in the millimeter and R is in the meter and R in few centimeters or meter and A is in millimeter. Then only short dipole concept. Here it is not a short dipole, R is equals to, it is AB. For a dipole, I repeat, the R is nothing but distance between the midpoint and the point. For a single point charge, R is nothing but distance between the charge and the point. Okay, don't confuse with the R. In both the cases, for single charge point case also, it is divided by R square is given. For a dipole also divided by R square, but for a dipole, this R is nothing but distance between the midpoint of the dipole and the point where we get to work out the field. For a single charge, R is nothing but distance between the charge and the point. Okay. Now R is AB, that's equals to 0.05 plus 0.05, 0.1 meter. 2A is equals to distance between Q1 and Q2, axis of the dipole, 0.1 meter. Therefore, A is equals to 0.1 upon 2, that's equal to 0.05 meter. A is not small as compared to R, therefore not a short dipole. It is not a short dipole. Therefore, short dipole formula should not be used. It is not a short dipole. Now, E B bar at once we can work out. by using the what it is dipole formula. The field on a axial field on a field at a point on the axial line. Okay, but the point should be external point on the axial line. That formula is EB by directly 1 upon 4 pi epsilon naught. I would like to put the field at B as well as field at C. C is on the equatorial line and B is on the axial line. That is external point. For external point only this formula is applicable, not for the internal point of dipole. Okay, 1 upon 4 pi epsilon naught 4 QAR upon R square minus A square the whole square. Suppose it is a short dipole, then it is 4 QA upon R square minus A square should be taken as R square. R square the whole square, R cancels, R upon R raised to 4 is R cube. Is it not? For a short dipole it is 4 QA upon R cube. But for not a short dipole, long dipole, this formula should be taken into P cap. Okay, that's equal to 9 into 10 to the power of 9 and 4 into Q is 10 raised to minus 8 into A is 0.05, R is also 0.1 divided by R square is 0.1 the whole square minus A is 0.05 the whole square. The whole square will be taken, did not. R square minus A square the whole square. Let's check the formula. Okay, let's check the formula. It is 4AQR upon R square minus A square the whole square. Okay, correct. Let us work out. Put off and do the calculation. 9 to the 36. 36 into 0.1 is 3.6. 3.6 into 0.5. That's equals to 0.18. Okay. 0.18 into 10 to the power of 8 into 10 to the power of 9. That's equals to 10 to the power into P cap. Direction is P cap. 10 to the power of 1 divided by, am I right? 9 into 9 for the 36. 36 into 1 is 0.36. No, 9 for the 36 into 0.1 is 3.6. Okay, 3.6 into 0.5 equals to 0.18, correct? It is 0.1 square, 0.001 minus 0.05 square, 0.0025 0.0025 equals to 0.0015. Am I going wrong? 0.01 is 0.01 minus 0.05 the whole square, 0.0025 equals to 0.0075 the whole square into equals to 0.40562. Okay, what out in the calculator? 0.1 square is 0.01, 0.05 whole square is 0.0025. Minus is taken, then whole square is taken, R square minus A square the whole square. Yes, it is. And square is taken, 0.000040562. Okay, so let us shift the point 4 place, but it is right. 4 place, right? Therefore, it is 0.18 into 10 to the power of 1 upon 562 into 10 to the power of minus 2. Sorry, let us do direct calculation. 0.18. Now it is, let's do one thing. 0.18 divided by 0.0000562 equals to 3202. The answer is 3202 10 to the power of 1. The point is shifted 1, 2, 3 is equals to 3.2 into 10 to the power of 4 into the power of 4. Okay. P cap. Direction should be given. P cap. This P cap is maintained as it is. That's equal to point is shifted 4 to the right. That's equal to 3.2 into 10 to the power of 4 newtons per P cap newtons per meter. Okay. Newtons per meter. This is an exercise problem actually, but he has not used the dipole concept, but use the dipole concept. Calculation becomes simple. Okay. It is correct. 3.6. Now, point C is on the equatorial plane. Point C is on the equatorial plane, but what is the R? Distance between A and C. That R is to be worked out now by Pythagoras theorem. Okay, for the point C. C is a point on the equatorial line. Okay, third one. C is a point on the equatorial line. Equatorial line. R is equals to CP. Sorry, C. R is the distance between the point and the midpoint. So actually, by Pythagoras theorem, it is the right angle triangle. No, DC square plus what it is AD square is equals to Pythagoras theorem AD square plus AC square. Therefore, DC square is 0.1 the whole square. AD square is 0.05 the whole square is equals to AC square. Sorry, minus is taken to this side. Therefore, 0.01 minus 0.0025 is equals to AC square. AC is R square. Okay. Therefore, 0.1 minus 0.0025, 0.007. Here it is, only two zeros. It is 0.1 minus 0.0025. That's 0.0075. Okay. 0.0075 R square. Therefore, R square, time being R square only, let us take R square is equals to what? I got 0.0075. Now coming to the formula. See here the point on the equatorial line. Therefore, EC bar is equals to 1 upon 4 pi epsilon naught, and the formula is the dipole. Not a short dipole, it is minus 1 upon 4 pi epsilon naught into 2QA upon R square plus A square raised to 3 by 2 into P cap. Okay. Okay, P cap is unit vector, directed form minus Q plus Q. P cap. Directed form minus charge to positive charge. Okay. That also is not the figure form. Okay. Now substitute everything. It is 1 upon 4 minus means it is minus 9 into 10 to the power of 9. 2 into Q is 10 to the power of minus 8, R is 0.05, sorry, A is 0.05 upon R square. R square itself is worked out 1 upon 4 pi epsilon 9 into 10 to the power of 9. Okay. R square itself is given there. It is 0.0075. 0.0075 plus A square. A is 0.05 the whole square. Okay, 0.05 the whole square. Anything is missing. 2 times of Q is written 10 to the power of 8. A is 0.05. This is the A. 2A is 1 meter. 0.1 meter. A is 0.05 meter. That's equals to minus 9 into P cap. Okay, 9 into the 18. 18 into 0.05. 18 It works out to be 0.01. Okay, 0.0075 plus 0.0025. That's equal to 0.0075. R square itself is 0.0075. Okay. Therefore, 0.0075 and 0.0025, that's equals to 0.01, correct? 0.01 raised to 3 by 2. How to work out raised to 3 by 2 then? Please mind into P cap, direction. P cap is the direction. P cap is the unit dipole moment directed from -2 to +2 here. Okay, minus of 9 upon 0.01 raised to 3. 0.01 whole raised to 3. Raised to half means square root. Raised 3 by 2 means the a raised to 3 by 2 means a cube raised to half. That's equal to a cube square root. Therefore 0.01 the whole cube. 0.01 into equals to twice square root of that one. Okay. 0.00, okay, 0.001. Then 9 upon 0.001 is, it is minus into p cap, the minus 9 into 10 to the power of, it is 10 to the power of 3, no? 0.001 is point is 3 place right, 1 into 10 to the power of 3, 1 into 10 to the power of 3, okay. Point is shifted to 3 place right is 10 to the power of plus should be taken, right side plus, left side point is shifted 10 to the power of minus. And therefore 9 into minus, shifted right, shifted right minus, shifted left plus, point is shifted right and it is minus 10 to the power of minus, point is shifted left 10 to the power of plus, 10 to the power of minus 3 is taken as the numerator, it is p cap, this 9 into 10 to the power of 3 into p cap newtons per coulomb. Okay, answer is correct. 9 into 10 to the power of 3. So I have used this is an actually solved problem, but without using the dipole concept, he has solved it. But that process of solution is lengthy one. For the midpoint, the usual point charge concept is applied. Okay. Now, I will give one more homework. Okay, a simple problem, not on dipole. This is a problem on dipole moment. An electric dipole, it is exercise number 1.10. Just I will read out the problem. 1.10. Exercise 1.10. Okay, 1.10. An electric dipole with dipole moment 4 into 10 raised to minus 9 coulomb meter is aligned at, it is a torque on the dipole. Another problem, 1.9 it is, work out the 1.9. Okay, time is up. Tomorrow I will see. The next class I will see. Exercise 1.9. Exercise 1.9. You can try as a